Yeah, welcome from my side. My name is Andreas Faath. I'm leading the topic OPC and interoperability inside VDMA. What I will show you next is what is a VDMA, and this is critical important to understand. The VDMA is Europe's biggest association in the field of mechanical engineering and manufacturing. We got over 3,200 member companies, so it's not only people, it's really about the companies. And for that, we are structured in 38 smaller trade associations representing different branches in this big industry. So what you need to keep in mind while I'm talking and telling you about interoperability and OPC and what we are doing is that those branches inside one big industry are under one umbrella named VDMA, are connected and can talk to each other, can collaborate, and can do by this reach the goal to have really an interoperability also between different branches inside the mechanical engineering. Of course, we're working worldwide, so we got a bureau, an office in Brazil, we have China, we have Japan, so we are spread and representing the European markets, but also the world market everywhere internationally. So, to put it in a nutshell, the VDMA is representing the broad manufacturing industry under one umbrella. And the mechanical engineering industry was forcing the VDMA to go for interoperability, to standards in interfaces. Because the problem we all have to face is that different interfaces are really hard to develop. It's not efficient to do different interfaces for different users and also for the different machines again and again. So what we were looking for is a technology, an architecture, something like that, which is secure and which serves for the basis for an interoperable companion specification communication between different machines with one language and with a kind of self-describing possibility of the machine itself. So what we are doing really is the OPC companion specification development. That means we are not developing OPC as a technology or going deep in this technology for protocols and so on. We are really taking the technology OPC and bringing the OPC companion specification on top of that. That means this is kind of a remote control, a universal remote control. So what you can compare is this universal remote control where we have 0 to 9 on, off, next, and reverse and something like that. What we're not doing is the vendor-specific extensions. In those, you have really the market-relevant information which can be compared, for example, the red dot on this remote control with this little girl. Well, you can maybe on the Samsung have a time shift, on a Sony you have something totally different. This keeps to the companies. What we are doing is to figure out the basis where all the companies working in our working groups can come together and say, this is what we all have in our interfaces. This is not worth to do again and again and again in development. What you can see here is the structure of the VDMA, and colored in blue you see all the groups which have right now companion specifications under development, and in orange you can see those who have a release or a release candidate. So what you see is that really a lot of our trade associations representing the different branches are right now in the development phase of OPC companion specifications. I will deep dive a little bit in some of them, and I cannot explain all of them, but maybe I heard food processing machinery and packaging machinery is pretty important for the local market here. So here the group of Weinstephaner Standard, maybe you heard of that, is translating exactly this existing Weinstephaner Standard into OPC so that the information which is standardized in this Weinstephaner Standard is put into OPC and can be used in this technology as a companion specification. Right now we got over 17 sector branches which are developing OPC companion specifications. and we have over 26 working groups. So that means it's not like one sector branch is having one working groups. It's like some of the branches have 2, 3, 4, 5, or even 6 working groups running in parallel or sequential. And right now there are more than 450 companies really actively working with us in those companion specification working groups. And this is really a big impact. And this is why we're having the VDMA really taken as an umbrella for a neutral ground to bring the companies together, to let them talk about their interfaces and to see what can be standardized and what is not that market relevant that you have to bring it only to your own company, but you share it in the group. Those companion specifications, of course, don't fall from heaven. That means we got a process. This process has 5 bigger parts and 2, I would say, ongoing parts in parallel. And I will explain this process on the example of the robotic working group. So at first you see the preliminary work. That means our groups have a kickoff, they are starting, they are checking in the branch, what is the need, is there a need, are there customers maybe or users that should be integrated, and so on. So in this group, as you can see, these are the core working group members. So you see here VW, for example, as one of the big users. And as Stefan mentioned, it's also a joint working group. So this group, of course, the domain knowledge is coming from the domain experts, but a lot of OPC expertise is also coming from the OPC Foundation, and we are working here closely together. For the part of content work, it's pretty important that the group is thinking about their product, their machine type, and maybe there is a possibility to do a little abstraction. So if I look in your faces, all of you have different robot in mind. Some of them have 2, 3, 4, maybe 6 axes. So it's not worth to do a companion specification for a precise, detailed robot with maybe 6 axes, and maybe it's also orange. It's really important to get one abstraction level above that and think about what do we all have in common. So they came to the point and told we are all doing motion devices, motion device systems. So they go for the goal that they said, not a specific robot, make an abstraction, think about what we all have in common, and therefore they go for this motion device system, which can consist out of the robot itself, the motion device, also the status and also safety states, and of course controllers. This is directly shown in the design in OPC where the domain experts are putting their knowledge, their idea of the interface into OPC technology. So for that, they are starting in this case and say there's a motion device system. This motion device system contains out of a motion device or motion devices, out of controllers and out of safety states. So the next step was to make clear what is a motion device system. And the most important things in this motion device system, of course, are axes and powertrains, because this is what the motion device makes the movement. Then they did an axis type where they said, okay, all the axes can be described the same way. So now here you can also imagine if we have 3 axes, you're using this axis type 3 times. If you got 6, you would just instantiate it 6 times. So no matter what robot you had in mind, you can bring this companion specification for that. And of course we have the motor. Powertrain time consists of a motor and a gear, so they also describe that. For the controller type, it's almost the same. They told, okay, we have software, we got task controls. They put task control in a more detailed level, and they got safety states, where they have the safety state here. And what is pretty important is everywhere you find a 2 on front here, this is derived from the DI specification. So there is a specification, I think Stefan mentioned that maybe, which is given by the OPC Foundation, and there are described basic information, and this is taken here into account and brought into this robotic specification. And also all the variables are pub-sub capable. So you heard in the morning there's client-server and also pub-sub communication, and the design was made from the scratch that is also pub-sub capable. Publication. We are doing this companion specifications on the one hand from a VDMA Einheitsblatt and also the OPC Foundation companion specification. And we know OPC Foundation has an own homepage where we can download all of that. But in addition, we also get a VDMA homepage. It's called opcua.vdma.org. And there you can find, on the one hand, the description of the different working groups. So they are all representing themselves and telling you who we are, what we want to do, what is the actual state, and what maybe are the next steps. And in addition, there is, on the other hand, a download area for companion specifications from the VDMA, where you can download also companion specification drafts. So not only the released final specifications, but also during the draft version, you can download this here and give comments to the working groups. Use in the industry, pretty important. And this is also something the group of robotics has to forecast somehow, to bring use cases in the specification and to make the users known their benefits. So there are some benefits. One benefit is condition monitoring. I will show you later a short demonstration on that. Well, not a live demo, but they did a demonstration on Automatica Fair last year, where they showed a lot of condition monitoring and also the topic of asset management. So what you can see with this specification is that you have the same description of the information from different vendors and the same wording, same description, same structure, same behavior. So you just can directly compare the different information from the different vendors. And this was, of course, shown in this demonstration here. They had this interface shown at Automatica last year, and you can see down here the joining companies, and they had all their robot, which was live running on the booth at the Automatica Fair, given the OPC companion specification as a draft, so not the whole specification, but part of it. And it was all shown in this Microsoft Azure Cloud interface here. And if I ask you now how long this took, I will give you the answer. It was about 10 to 15 minutes to bring the companion specification on the robot and bring it then into Microsoft Azure interface, what is shown here. So pretty fast. This is the topic which is running all the way in parallel. Consistency is something which is pretty important for VDMA and also OPC Foundation, and we are trying to bring this topic directly into account from the beginning of our working groups. So we are trying to define the world production language where all the different machine types which are somehow working in a production are able to communicate with each other. So what I mentioned, one umbrella, 38 trade association, this is exactly what we try to take into account here to make it clear that a robot cannot have other words for the same thing, like, for example, an injection molding machine. And for the topic of internationalization, I will skip to the next example specification called machine vision. For machine vision, there is an organization which is even bigger than the VDMA. It's called G3. And just this G3 organization consists out of US, Japan, Spain, Germany, and China, and of course VDMA. And they have a group under the label G3 hosting the machine vision working group. And what all the working groups are doing, even if they don't have an even bigger European sector committee or worldwide organizational part, we're having joint working groups with the OPC Foundation. So OPC Foundation for us specifies OPC and of course OPC is using those companion specification. And the VDMA is hosting the working groups, having the domain knowledge in one room, and OPC Foundation accepting those working groups by a joint working group. So that means that all our working group are really closely collaborating here with the OPC Foundation. They have more than 60 companies with more than 100 participants in these groups. And yeah, as I said, this is really something which started from the scratch. So normally our working groups are checking before they start their development of the companion specification, who could be taken into account, where are stakeholders worldwide, who should be in this group, who should be involved. And in this group, you see here the co-working groups, companies, and they started early 2017 and released their release candidate last year also at Automatica, and they had their release at the OPC Automotive Day, which was in May at VW. A machine vision is pretty complex. You saw the robotics, and in robotics it was important to have the components in mind, how it's built with axes and controllers and gears and motors and something like that. For a machine vision system, it's pretty hard to think in components. It's really more a complex system which is driven by software. So for that, the group has to face to the problem that they cannot easily describe their machine. So what they did is to think about what do they have in common, and this was the topic of the behavior. So they said there is a configuration management, there is a result management, and there are inputs and outputs. So they left the black boxes in there, but they defined how those data goes in and out of the system. And in addition, they have all the same behavior. And for the behavior, they did a state machine. This is a top-level state machine with a pre-operational, halted, error, and operational states. And what you can be sure if you are buying a vision system with OPC companion specification on site, that all of those have the state machine on top level. So this is a mandatory state machine. So all of those vision systems will have exactly those states. There are even more state machines on lower levels, which are, for example, describing the error state more in detail. They are more optional, but this first level state machine is mandatory, and you can count on your machine vision, if it has this companion specification on site, will bring you this. UMATI. UMATI is going for tooling machines, really a big activity here, and they are trying to do, of course, also a companion specification, and they said our problem is that in one production, also in one line, we have tooling machines from different manufacturers, and we see that the integration and also the running of those tooling machines have a really big effort for interface development. So they said we want to have UMATI, a universal machine tool interface, which is covering the most important information a tooling machine can give to the systems, to the production. So what they did really is to have, on the one hand, this UMATI, and this UMATI has, at the one hand, the basis information which is standardized, and on the other hand, there is pretty clear described how the vendor-specific extensions can be used here. So I told you about vendor-specific extensions. Of course, all of the working groups have this somehow in their specs, but they are really bringing this, I would say, a little bit more explicit in their specification. And it is already a worldwide standard. So the standard is not released yet, but the group who stands behind this standard is totally huge right now, and it's really internationally spread. And what you see here is the overview of the partners. You can see here the core partners, but right now it's really huge and it's growing from day to day. They started, and this is pretty impressive, they started last year, around this time in the year, and had their first outcoming at the AMB last year, and this was where the UMATI label, the UMATI, the name, the logo was first time shown to public. And it was only those companies were behind that. And by now you can see it's really spread, and really a lot of tooling machine companies, but also some other partners and research partners and so on really joined this activity, and it's gaining more and more relevance. And as we think about UMATI, it will be the tooling standard for the whole world. So what is being standardized? Some of this is already standardized. Well, of course, it's doing development right now, and something of that will be standardized. And it's really about use cases which are describing the field of parameters. So we will have an easy and fast overview of the production on the side of tooling. You will have an overview of the jobs which are running on the machines, and you will have the status, you will have statistics, for example, for errors, and of course you will have a lot of more functionalities. And right now they have more than 100 parameters and more than 20 use cases. Some of them are really, I would say, developed in detail. Some of them are really under development right now, still roughly. But this companion specification will have a lot of parameters and will cover a lot of the use cases a tooling machine can have. They had 1 year after AMB, they had the first demonstration. This demo was live running at the EMO fair in Hanover last month. And as you can see here, they started with about 10 companies, and now they have over 70 companies which had a live running machine tool on their booth connected with UMATI. So it was more than 110 companies, 110 machines of 70 companies with 28 software solutions, and the companies came from 10 different countries which had their booth on this EMO fair, and they all had the UMATI interface used. And at the UMATI booth you had the big screens with the interface showing the actual states, the actual information, and everything which was implemented right now with UMATI. And what was implemented you can see right here. Here you see, I think I'm a little bit in the way. Here you can see the most important use cases they are having in their companion specification. And on the EMO demonstrator, they had the identification, of course, of the machines and different manufacturers, and they have the overview of the production is running and overview of machine tool state. So what you were able to see is the different machines from different vendors having different states, colored, green, yellow, red, if it's live running, if it's right now in a pause, or if it's have an error, or even if there's no color, it's just switched off. So you're directly able to see the performance of the different machine tools running on the different booths. So it was pretty interesting for me, for example, that there were some machine tools just running the whole night. Nobody's on the fair, but the tools are running. And some of them had the whole night in error. Some of them were just switched off. And this is something you can imagine to have it in your shifts, in your production. Yeah, as I said, huge group, open for participation if you're VDMA, VDW, or OPC Foundation member. And if you need to get in contact, there's a mail, umati@vdw.de, or even a homepage, www.umati.info. Just get in touch with them, totally great. We got Euromap. Euromap stands for Plastics and Rubber Machinery. Euromap also, as kind of G3, but only for the European market, not worldwide, is an organization which consists out of different associations spread over Europe, and they are working also together with the Plastics Industries Association, they with the Japan Plastics Machinery, Taiwan, and different organizations doing plastics and rubber machinery topics worldwide. So again, the VDMA is hosting this association, but we are going here totally under umbrella, under the labeling of Euromap. And Euromap There are different machines of the plastic industry, plastic and rubber industry covered, so it's not only about injection molding machines or only about extruders. It is really the whole broad machine type range we have in Euromap. And what they are doing and what they did also, so this is one of the first comers and they have some specifications released already, is that you will have basic information, you will have the configuration of the machines, you will have, again, like in UMATI, different stages and of course error information. So this is one of the most important basic information you get delivered by the Euromap specifications. And again, they have use cases, job management, management of recipes, or for example, the specification of individual set points here. So it is not like we have just a flat list of different information or variables. It's really about structuring, about thinking about the use cases, how this information will be used, and then describing the whole use case in one specification. And not like you have 20% of this one use case, 30% of a different use case, and maybe 70% of a third use case, but a use case is not fulfilled completely in one specification or in some specifications. So it's critically important for all the groups to bring a kind of benefit to the user, and this is always somehow given by use cases. They have one specification which is kind of the mother specification, it's the Euromap 83. And this Euromap 83 is describing on the highest level plastic and rubber machineries. So you will find there no specific information, for example, of an injection molding machine. It's really more about manufacturer ID, temperature zones, and so on. What they did is then have one layer down of that, and all of the other specifications are deriving from that Euromap 83. They have different more specifications, for example, 77, which is for injection molding machine to MES communication. Or they have 79, which is for communication with injection molding machines and the robot. So here you can see it's also in the name of the specification. There's a use case where the communication partners are described. In Euromap 77, it's pretty nice to see how this group was set. So there was one trigger, this was Lego Systems. Lego Systems really came to the VDMA and to the group and told them, we're having so many injection molding machines and MES system is so important for us. We need somehow an interface, a standardization. It makes us crazy not to have here a standard in the interfaces. And in parallel, this group of injection molding machine manufacturers came together and said, yes, of course, we have the same problem, not for the integration, but for the development. A user is not asking for our machine one interface. We have, for the same user, we have also different several interfaces, and it costs us a lot of money. So the injection molding machine manufacturers came together and were able to really have a companion specification working group. And as you can see, this is Euromap 77, so injection molding to MES. They also has MES suppliers inside. So they took some MES suppliers and also have the other side of the communication in this working group, and also the controller manufacturers who have to somehow make it possible to use the companion specification in the real production. I will not explain all of the parts here, but what for you interesting is that we have the Euromaps 82.x, so there are really a lot of parts coming, and this is always for peripheral devices. So it's, as you see here, it's for hot runners, it's for LSR dosing systems, and so there are coming more peripheral devices which will be covered in this series of the 82. And they have the 84 line, which is more for the extruders, where they have also, again, a lot of different specifications for extruders for the Hall-off, melt pump, die, cutter. So also a lot of peripheral devices which are somehow described. So as you see here, a lot of release candidates. So all the 84s are the release candidates. So in the phase of commentation, that means they will be as a release, I would say the next 2 or 3 months they will be available as a release. Also under the OPC Foundation companion specification site. And what is also important and what we are forcing our groups to is to do plugfests. So what we don't want is to do only paperwork. It's not worth to have 1 or 2 years in development of such a specification and then bringing out a product which is just paper, which is not implemented, which is not tested. So our working groups are doing demonstrators, are doing plugfests, are somehow checking the quality. And yeah, of course, it works for them. So they had, I think, 3 2-day plugfests where they really were debugging a lot. So it's not that easy to do a high quality specification without any plugfests. So they came with their controllers and with their software inside to the VDMA, and they have their switches and try to communicate, to exchange information using the specifications. And yeah, it works.